the Croc. Powerful, fashionable, comfortable, ergonomic, off-road. Words that you would not associate with the Croc. Safe. So, let's go out and amend that by making Steel Capped Crocs with water. So, to make the cap for the shoe, we're going to use hydroforming, which means we need to make ourselves a tool to push the steel into, and we'll push that steel in rather than with another tool or a die. We'll actually use water in that placement. There's a couple of benefits. One, it's cool. It's a big deal here. Also, it doesn't leave any tooling marks, doesn't require any pressing, and you're just more likely to achieve, the desired result with less tool making skills. I hope. Anyway, that means we need to make ourselves the tool. We need to get the Croc into the computer. So, what we're going to do is scan it. How we're going to scan this? With photogrammetry. It's easy, anyone can do it. We'll take a whole bunch of photos, about 200 to be honest, and then put that in a software. It will spit out a mesh, and then hey presto, we can start modifying that mesh into a tool. Anyway, let's crack on. Oh, crikey. Right, now we have our tool. First of all, photogrammetry worked out amazing. Really dense mesh, and it's actually accurate, so that's fantastic. Anyway, we've got our mold, we've got our left and right Croc all in one. It increases our cross section as well, which makes it much easier to get the depth required when you obviously inflate the steel. Now, if you guys are a tool specialist or a hydroforming tool specialist, please in the comments below give us some advice. We are flying blind here. I have read a paper on it. I'm not that much wiser, I've got to be honest. So, we'll hope this works. Fingers are crossed. Right, the mold's sanded and smooth, so what we need to do now is mix up our plaster of Paris so we can cast into it. Look, I don't think any more bubbles are coming out. I've probably sanded through the whole bench with that. Sheesh! While the mold sets up over there, we shall jump over to the plasma and do some plasma cutting. Right, we're about to close up the mold. Now obviously we've got our little plaster casting here. Now you're not going to see that getting demolded because that was truly horrific. That is in about 10,000 pieces now. So if you guys do this at home, make your 3D printed mold 2 parts so you can actually pull it apart and there not be any issues to your very delicate plaster because the bottom edge is ruined. But that's okay because we're about to fix it up in post. I hope. Fingers crossed. Anyway, let's bolt this all up. Right, I think it's about time we address it. How much aluminium do we actually need to do this? About 10 kilos. That's 3.2-ish litres of aluminium. That's a lot. That's an obscene amount actually, so I don't actually know if that's true, but we'll find out. So, 100mm box section-ish. Up 300, that's just 3 litres, so we've got 400 at least for the crucible size. That means we need to definitely modify our forge furnace, our Vergis, to cook our aluminium. So using this pile of scrap that I've been saving for this exact job, let's modify it. Let's extend it, which will be the reverse of that. Right, the aluminium we're going to use for the casting is this. More specifically, the head of a Nissan, not Nissan, you American folk. Has amazing flow characteristics, great surface finish, and it doesn't compromise on its strength. So, ideal for our circumstance, because obviously we'll be able to totally replicate the environment that this was cast in factory, won't we? Right, we're about to pour it, so I'm just heating the mold up, and then, yeah, we'll be casting. Well, overall, not a success. The you can see the bubbles really, can't you? That's obviously from the plaster of Paris, all the water inside it just, you know, vaporizing and ruining it. Now, the upside, we were able to melt, you know, such an extreme amount of metal. The cast looks beautiful on the outside, so those are big ups. The downside, can't get the bolts out, and obviously the forming did not work, so that's not ideal. Right, after our first testing, we're on to Mark II, which we shall use green sand for. Literally silica sand and bentonite clay. Now, silica sand can be substituted with any sand, just make sure it's really fine. Bentonite clay, cheapest clay cat litter is bentonite, usually. But don't get fragrance or odor suppressant. It's usually just baking soda, but that might, you know, do weird things with your casting. Now, I am speaking from authority here. I have clearly watched a YouTube video and I've read an instructable on how to do this. So I am well versed in the theoreticals of green sand mixing. Anyway, let's get on with it. So we've got 1 kg of sand, which means we need 120 grams of the clay, so then we get a 12% ratio. And then water, I'm just going to spray it on while I'm mixing, and that will just give me, you know, a bit of an estimation of how much you need. It's meant to be damp. That's kind of the explanation I've found. So yeah, we'll do that. Now you'll also see me hammering it, like tamping it down. That's called mulling, and that's how you kind of coat each grain of sand with the clay. Who knows how it works? We're finished mixing up our green sand. Looks just like brown sugar. Doesn't quite taste the same though. Anyway, we need to fill up our mold, tamping it nice and evenly. Let's hope it works, eh? I'm happy with that. It's come out amazing actually. Now, it's not perfect. There's a couple bits there, the back there's a bit of rubbing, a bit of porosity, but that's okay. Porosity's fine, because it means aluminium goes into the sand, and we just have to sand the aluminium mold back, which is okay, we can do that. But if we have sand sitting on the surface, that goes into the aluminium, we either have to clear it out, and we're left with, you know, porosity in the aluminium. We have to weld aluminium, that's not going to be very fun, and this medley of cast aluminium, yeah, that would not be fun to weld. And then you got the grain of, we're not going to go down there. Let's just make sure that we don't have to deal with that. Anyway, we're going to start melting aluminium. You've seen that before, so I shall see you in 3, 2, 1. I'm just addressing the fact I'm using channel locks. Do not recommend, but the bottom hook melted off, so in my frantic panic, I grabbed the closest thing and they were channel locks. Just thought I'd address that. You can hear it's not perfectly smooth, but it's definitely good enough. Very chuffed. It's also extremely heavy and unwieldy. I'd hate to drop this on my feet if I had Crocs on without steel caps, so, you know, it's solving the problem that this creates. We've got our beautiful block done. If you look at all the holes, it kind of looks like it was done by a machine. That's just how precise I am, until you obviously look closely at it and then you realise they're all a bit skewed, but that's okay. We now need to sand that face butter smooth. Yeah, that's never coming off. We need a breather hole. If we don't, the air pressure, because it's sealed, will build up and maybe create an artifact, or at least all the oil in there from lubing the mold up will hydrolock. You're just left with small artifacts and stuff. Probably not very good. Okay, we are at the very exciting stage of prepping for our initial test. This is our wear face. If we were clamping our, you know, blank to this and it pulls in, it's going to wear out very quickly because it's obviously soft aluminium. So we go in with a wear face of core 10, again super hard wearing. Then we have our actual blank. This will become our Steel Capped Crocs. It's 1.2 mild steel. I know, very ambitious, but hey, we can only go down from there. With that in place, we can put our bottom sandwich plate. That is just to hopefully reduce the chance of there being any catastrophic damage to the base plate. Right, that is it for our Steel Capped Croc sandwich block. There we go. That is it. Anyway, let's do all of this. Then we can jump outside and actually do our first test. Okay, we've got it all set up, got the water blaster plugged in, I've already bled all the air out, so shall we give it a go? Right, starting off with the fact that the forces that I'm dealing with are just mind-boggling. The wear face is bent, it's now got all the edges are pulled in. And obviously the final result of this hasn't gone as far as we needed. It's about a third of the way, so really is quite far off. Getting good edges though, but they're too sharp. So this edge is just far too sharp. It's acting like a shear, so we need to deal with that first, and then we can come into making our actual template, our blank, having slotted holes, so then it can actually pull in a certain distance so it can borrow that material. Does that kind of make any sense? My plethora of semi-successful tests. Number 3 was really my last successful attempt. It actually sealed, which is more than I can say about the rest. Number 7 did get the most deformation, but it wasn't sealing, it was kind of got there after like 3 attempts of putting it in. Yeah. Anyway, I think I've identified my issues. Fillet on the mold, that's reducing the amount of actual clamping force close to the edge, so as soon as it gets close to the edge it can just bypass through the slot, you lose all your water pressure, no forming is occurring. So we'll hopefully address that by facing it. Now we're going to knock it down 15 mils, maybe a bit more. That's to reduce our total depth to success, because trying to go in 68 mils is very ambitious, so hopefully bringing that down to closer to 50 mils is just ambitious. Yeah. Especially with the 2-degree draft, eh? Anywho, the other thing, these bolt holes, yeah, it's strange. They're like all missing threads now. Yeah, really weird. So we'll drill all the way through and use we'll just use through bolts. And hopefully be able to torque up this metal sandwich and get it to work as intended. Now, my friend has very kindly offered to do this in his mill. Don't feel bad. It's not up to the task, is it? Anywho, let's do that. Now to pressurize this whole thing, I'm using just a standard water blaster. It's putting out around about 2000 psi, which is a lot, but because it's all hydraulics, it doesn't have a whole lot of potential energy. Unless you didn't bleed the system of air, then it becomes very dangerous. Right, I believe I have finally found the issue with the mold. Very exciting. Now, for reference, this is the newest one, and that was number 3. So we've gone downhill in our inflation. And the issue is it's lack of pressure. We're not actually building the pressure up because it's just leaking straight out. What's causing that? Well, we've changed the bolts, which you wouldn't think is the issue, but that is all unengaged thread. Or dead bolt, I don't know what you call it. It's just not engaged. It's a really long bolt before it threads at the other end, and it's just stretching like a little rubber band. We'll get M10s and a high grade, so we get M10, 8.8, so we can actually torque them down to like 50 Newton meters. All of that to me screams less stretch, more better, success. Probably not quite like that, but I'm hoping along those lines. Anyway, that means we need to drill out all of these holes, and there's no turning back. Success! Doesn't look like success, but I tell you, we fixed the leaking problem. No longer an issue, but we've created 2 other issues in solving that, which is not awesome. Anyway, first of all, the shear. It's ripped apart because the tools act like a shear. The next thing is the fact that there's been very little drawing. The material has not pulled in. The slots have not been utilized at all. It was before, which is telling me the fact that we now have too much clamping pressure. I did not think this would be an issue, but obviously it is. So, what I'm thinking, we do 2 stages. First stage is at that lower torque setting, and then we bump it up for the final oomph, where we can maximize the pressure and fill up the mold. I think that's the way to do it. Anyway, I have no idea. We shall continue the testing, and I'll get back to you if there's a new development. We are very close. Now, we didn't access or didn't utilize all of the slots, but more than we did before. But as you would have saw, the water blast was maxing out, so I believe we need to up our power game. So, using our grease gun, I think we'll be able to get this to work. I don't know, but I think we can. Converting to grease was game changer. We had access to 10,000 PSI now, where before it was only 2,000. This did give us the pressure to form, but came with its own issues. Most of them were linked back to sealing. This meant we had to Teflon all the bolts. I had to whetstone all the faces, every single use. There was just a lot of maintenance, and it was very tedious to ensure that it would actually form. Look at that. Gorgeous. We have done it. We now have fully formed Steel Capped Crocs that is repeatable. Obviously that's the key thing, because if you look back at our mold, oh, look at that. We had perfect success in the past, but you do the exact same thing again and it doesn't work, which is not so ideal. Anyway, I resolved those issues, and now we have the set. What we need to do is obviously cut them out, mount them up on our glorious footwear. Right, let's crack on, hey? Right, so I'm just cutting them out, obviously. Now, something I thought was really interesting. If you look at the cross section, you can actually see the thickness change and vary throughout the stretch. So, like down here at the flatter section, it's nice and thick still, but right in this corner, geez, paper thin. Pretty interesting. Anyway. It is that time now where we need to harmoniously pair the steel cap to the croc to form the Steel Capped Croc. Now, originally I was going to glue them, but I've changed my mind. I don't permanently want this very high status symbol of something on my croc, so I shall make them removable. Now, how am I going to do that? Well, with these, like buttons. Very like buttons. You just pop them in into each, the side slot and the top, and hey presto, we now have Steel Capped Crocs. Fully finished our steel caps for our Crocs. Now what's left is to film a comically intense film sequence and then test them out. It is now that time where we need to find out whether or not our Steel Capped Crocs will actually protect our feet. Now, to the astute viewer, you'll have noticed
I don't currently have them on my shoes. That's because we need a control. So, we shall drop this really heavy, I assure you, chunk of steel on my footsie. 3, 2, 1. Ah, my foot! That really hurt. It may be a bit of a surprise, but I actually pulled the wool over your eyes and substituted my real foot with some carrots. Now, as you can tell, there's been carnage. I not only have lost 3 of my 3 toes, but there's also been significant crush damage, and I don't think I would be quite walking away from that. Right, we have our anatomically correct carrot's foot inside the croc. Let's see how well the steel cap protects our feet.
They ask you how you are, you just have to say that you're fine.
Look at that! They're still alive. Our little carrots, or our toes in this obviously situation, are fine. So even though our steel cap has been mortally damaged, our foot is okay. Well, we've done it. We've manufactured ourselves a set of steel capped Crocs, and they look alright. Now obviously this is just proof of concept. They're a far cry from refined. The process itself definitely needs to be sped up. It takes a very long time just to form each one. And they don't really protect your feet. They're probably more of a hindrance, that's probably a big issue, to be honest, isn't it? Anyway, I digress. I'm definitely going to wear them. I think they look fantastic. Now, I'm only covering the tip of the iceberg. There was so much involved, a lot of learning. Let's put it that way. But yeah, we're now here. Crazy. Anyway, if you guys enjoyed this one, then possibly leave me a thumbs up. I would really appreciate that. Maybe even a subscribe. That would be pretty cool. Yeah. Also, huge thank you to my Patreon. Yeah. Anyway, thanks so much, guys. See ya.